Right, so trigonometry deals with relationships of sides of a triangle, okay? And when you have a right triangle, that obviously has three sides. We can talk about what we call trigonometric ratios, right? So take a look at this right triangle here. We know it's a right triangle because one of the angles is 90 degrees. And now we have two other angles left over. I call one of them theta. So that symbol that we write like this, like a zero with a bar in the middle, is called theta. TH, make the same sound of, like thin, right? And that actually, it's a Greek letter in the alphabet, and it makes the th sound, just like thin, like I said, right? So it's theta, not theta with an F, that's cheese. This is theta. It's a Greek letter, also like the go-to for an angle measure. Okay, so once we have this labeled as theta, now we can go and label the three sides of our triangle. Remember that the largest side of the triangle is always called the hypotenuse. That faces the 90-degree angle. Okay, so that's the hypotenuse. We take it out of the equation. Now here we have theta. We have these two sides left. They're called the legs of the triangle. One of the legs is farther from theta. It is the opposite side of theta. We call this one the opposite side. You see how it's not even touching the angle? The other angle, the other side here, is touching that angle theta. It's adjacent to it, right? It means touching. So we call that the adjacent side. So now we have three sides to this triangle that we labeled. And each one of them has a different measure. So suppose the measure of this was 5 and the measure of this was 10, right? So 5 is the side opposite to theta. 10 is the hypotenuse. So if I were to ask you, hey, what is the ratio of the size of the side opposite to theta to the hypotenuse? That's a lot. What is it? 5/10. So you can figure it out immediately, but saying it takes such a long time, right? So there has to be a shorter way of saying all that. Well, there is. That is called the sine of theta. Okay? So sine of theta, which we abbreviate as sine of theta like this, that's just code for, hey, what is the ratio of the side opposite to theta to the hypotenuse? So that's all it is. There is nothing like mystical about what sine theta is. That's all it is. So if I wanted to now say, hey, what is the ratio of the side adjacent to theta to the hypotenuse, I'll just abbreviate that as cosine of theta. Okay? So now if we look here, sine of theta becomes opposite to the hypotenuse, the ratio of the opposite side to the hypotenuse. Cosine becomes the adjacent side to the hypotenuse. So I compared opposite with hypotenuse, adjacent with hypotenuse. The only other pair I didn't compare was opposite and adjacent, and guess what? That's tangent, opposite to adjacent. Okay, so that's what those ratios are. And if you remember, back in the day, you learned SOHCAHTOA, right? So what did that stand for? Sine is opposite over hypotenuse. Cosine is adjacent over hypotenuse. Tangent is opposite over adjacent. Okay, so SOHCAHTOA. So remember that. Those will give you the first three trigonometric ratios. Those three trigonometric ratios have buddies. They have their reciprocals. So if I take opposite to hypotenuse, and if I take the reciprocal I get not sine, but cosecant. If I flip adjacent and hypotenuse to hypotenuse and adjacent, I get secant. And if I flip opposite and adjacent, I get cotangent, right? These are the reciprocal identities. Okay? Now, you have to remember that sine goes with cosecant. And you have to remember that cosine goes with secant. And everybody, people sometimes get this confused. The only way I have figured out to remember them is, okay, so these all start with S's and C's. So just remember that it's like opposite. The one with an S, sine, goes with the one with a C, and then the one with the C goes with the one with an S. This is like, there's no math involved in this. It's just the way I remembered it when I was your age, okay? Okay, so the 6 trigonometric ratios are, so let's see, we have this triangle here, and we want to find sine of theta and tangent of theta. Okay, so why don't we go ahead and do that? This is theta, right? I highlight this. Now, the first thing I want to do is label the 3 sides. Hypotenuse is the easiest one to label. Which one is the hypotenuse here? The 2. This is the hypotenuse, opposite of 90, right? Yeah. So that's the hypotenuse. Okay. So now I have 2 legs, the vertical and the horizontal. Which one is the opposite leg? 1. And which one is the adjacent? Correct. So what is sine of theta? So sine of theta is opposite over hypotenuse. Yep, that's 1/2. Okay, now it says interpret its meaning. So what is this? This is the ratio. So the meaning is that the ratio of the opposite to the hypotenuse is 1:2. Okay, that's a very mathy way of saying that, but how would you explain this to like an elementary school student? What does that mean that the ratio is 1:2? What does it mean about like the sizes? So for example, if this side, the opposite, was 5, how big would the hypotenuse be? 10. So the hypotenuse is always twice as big as the opposite side, right? So hypotenuse is twice as big, as long as the opposite. Okay, good. So now let's do tangent. Tangent of theta is opposite over adjacent, 1/√3. Okay. So you would have to rationalize this and make it √3/3. But now, so look, we decided years ago that past Algebra 2 and intermediate algebra, so starting with pre-calc and trig, you are no longer required to rationalize the denominator. Ever. You want to know why? Why? Because the reason why we rationalized it into √3/3 was because you could never divide by any number that was not a rational number. Because way back in the day, before calculators, there were slide rules, which is how like people would do these operations. With the slide rule, you could only multiply and divide by 3 or 5 or 7. You can never divide by it. So that's where the need to rationalize came from. But now that we have our calculators, it's not mathematically wrong to leave it like this. So you're allowed to leave it like that now. Okay? Okay, you know what though? We're going to go a little bit further. Can somebody plug that into your calculator? Like what's 1 divided by √3? Or what's √3 divided by 3? Yeah, you can't do that on there. Nobody can do it in their head? Neither can I. That's why. No? Okay. What do you think? 4 decimal places. Yeah. Is it 3 or 4? Well, 3 and the next one's 5. Okay, so 4. Good. Okay? So what does this mean? So this is the ratio of the opposite to the adjacent. That means the opposite side is always 0.5774 the length of the adjacent side. Right? So if you scale this triangle differently, whatever the adjacent side is, the opposite is always going to be 0.5774, the length of it. Yeah. No, because it's not 1 to 2 for this one. Yeah. Oh, yeah, in that form, yeah. This is fine. Okay, so find the exact values of the trig functions of theta. Okay, let's take a look at this for a minute. Exact value means no decimals. So either roots or fractions only. Okay, so we have all this in relation to theta. The first thing you're going to do is label, right? Which one of these gets labeled as hypotenuse? 13. Which one becomes adjacent side? 12. So 5 is correct. Okay, so sine 5 over 13, and that's it. You have to make sure it's simplified, and then you're done. Cosine 12 over 13. And what's tangent? 5 over 12. And then the rest, you just take the reciprocals. So 13 over 5, 13 over 12, 12 over 5. Okay. Next, we have the trig functions for the angle F. So again, first highlight that angle F. Now, which one of these sides will be the hypotenuse? 40. Okay, so is 32 the adjacent side then? No, it's the opposite. Good. And this is the adjacent. So sine is 32 over 40, but simplified to 4/5. Cosine is 24 over 40. I can divide top and bottom by 8. 3 over 5. And then this is 32 over 24. 4 over 3. Okay, now, the other ones, don't do the work twice, so just get that column, right? So 4 over 5 becomes 5 over 4, 5 over 3, 3 over 4. Okay. Do you all know how to do that on your calculators? How to reduce it on your calculators, right? Okay. Questions so far? Like you would, let's say, plug in 32 over 40. And do you know how to get 4 over 5 from that? Okay. Huh? That works. And then, or if you just press enter, first it'll simplify to 4 over 5, and then you have to do like control enter if you want to make it a decimal. Okay. Right, to make it a decimal, yeah. But then to reduce, just enter, huh? Yeah. Right. But again, that won't reduce, like you would have to reduce yourself on that one. Yeah. Okay. Okay. So now that was just a basic, okay, find sine, cosine, tangent. If you're given a triangle. What if you're not given a triangle? Instead, you're given a trig function value, and then you have to find the remaining 5 trig functions. So you're not given a triangle. You're given tangent of A is 5 over 3. So this is telling you there is some random mystery angle, A, the tangent of it is 5/3. So for this, use your SOHCAHTOA, right? Tangent is TOA. That means its tangent equals opposite and over adjacent. So I have, for the first one, laid out some steps for you. So when you're doing your homework and you have an instruction like this, follow these steps. Step 1, draw a right triangle and label the sides. So here's a right triangle. I'm going to make one angle A. I don't care. It can't be the 90 degree. And then of the other two, you can make whichever one you want A. Next, label the sides. This is hypotenuse. The vertical one is opposite. And this one is adjacent. Yes? Okay, now look at what I'm given. Tangent of A is 5/3. So 5 is the opposite. 3 is the adjacent. This is 5. This is 3. Okay, so we labeled. Now we're going to use the Pythagorean theorem to determine the missing side. This is the missing side. So remember, legs go first for Pythagorean theorem. 5 squared, 3 squared equals x squared. What's 5 squared these days? 25. What about 3 squared? So 34 equals x squared. So what's x? Okay, now look. Leave it that way because you're going to have to find the exact values, right? So leave it as root 34. Now, can root 34 simplify to a different root? How do you know? You do the factor tree. So this is 2 times 17 and that's it. So you're stuck. It's just root 34. Okay, so now this is root 34. So now sine is opposite over hypotenuse. Right, and you're done. So in the book, they'll rationalize. So they'll say 5√34/34, but this is perfectly fine for me. Okay. Okay, so what's cosine? Correct. And tangent, we were already given to be 5/3, right? Okay, so then we have the other ones. Cosecant, root 34/5, root 34/3, 3/5. Okay? So we laid out the steps on this one. Now normally these problems will just be given to you like this, and then you have to know to do steps 1, 2, 3. So why don't we do this a little bit more efficiently? What's the first step? Draw the triangle. All right, I'm going to draw the triangle this way this time because I can. And guess what? We're going to name one of the angles B. I'm going to be a rebel. I'm going to name this top one B. Okay? So this is the hypotenuse. Which one is the opposite to B, horizontal or vertical line? The opposite is the horizontal, which means this is the adjacent. Okay. Okay, I have secant. So which one is that? Secant goes with what? Sine or cosine? Cosine, which is adjacent and hypotenuse, but it's flipped, right? So it's hypotenuse and adjacent. Okay, what's hypotenuse then? 3, adjacent is 2. We got to find the missing side x. So what's the Pythagorean theorem going to look like? What squared plus what squared? Good. So 4 plus x squared equals 9. X squared equals 5. And what's x? Root 5. So what's sine then? Is that right? Okay. Cosine is the reciprocal of what we had, 2/3. What's tangent then? Root 5 over 2. And we're going to flip the rest. Okay, 3 over root 5. 3 over 2. 2 over root 5. Isn't that cute? Right? And this is where we're going to end today. And your homework is going to be on your lesson plan. Homework number 1, page 195. And this is going to be due the next time you're in class, which is 9/5.